So the first thing you may have noticed is about the homework from last unit. I was originally going to add 10% to make up for those two little assignment, I don't want to call them sections, but the two little assignments that I wasn't going to have you do. But then what I kind of made sure to look at the details of everybody's homework, and I basically saw that the only people who were at 90% or above had got to the 90% or above because they did those two missing sections that I was kind of accounting for. And usually my goal is to have at least half of you guys get 100% on homework, because I mean, like, it's really difficult to try to tie together the homework and hybrid and all this different kind of things going together. So I don't necessarily want homework to be a punishment against you if you've been doing it, right? And that's my goal. And when I say doing the homework, I mean like actually doing it. Like it's easy to tell once people click through stuff, and I don't take that into account. But what I basically saw was that most everybody was trying their best, and so I kind of extended it to be a 20% boost to your grade. So whatever you guys got in Khan Academy, I added 20% onto that. And that's just because I kind of saw a majority of the class had done all of their work and had included the two missing ones to try to bring their grade up, which is great. I don't have a problem with you doing that. But I could see that to make the scales balance out, I changed it to 20. Yesterday, so I had to be gone. It was kind of unplanned there. I guess it was an okay one to be gone for, though, because the video, if you had a chance to go through and watch the whole video, it wasn't a bad section. So the very first topic that you were supposed to cover was accumulation of change, which is kind of a fancy term. Basically, you were finding the area under the graph. That's really all it was doing. Okay. Accumulation of change is correct terminology. But the graphs that you should have been given for the accumulation of change section should have all been geometric shapes. So like I believe I saw quite a few of them with a graph that looked something like this. And you're able to find the area under geometric sections because they're just geometric shapes, like squares, rectangles, triangles. But the purpose of the section was, or the topic, is to get the area under of the curve. So like if the height of this function was feet per second, and the x-axis here, the length, was seconds, part of what you should get out of this information is if you're finding the area under the function, your answer for the area is going to be feet, because you took feet per second times seconds, and this answer would represent the number of feet traveled. Feet per second would be a velocity, seconds would be times, and if you take feet per second times number of seconds, you get feet traveled. So it's accumulation of change because it's something that's constantly being added up. And then the next topic was Riemann sums, right? Which definitely has a fancy name. This 100% is estimating the area under a curve using rectangles and technically a trapezoid. But usually if you have a curve, it's not something that you can know how to do the exact answer yet for. So if we were trying to estimate the area under this picture, we basically made rectangles that somewhat fit it. Now the only difference between these different assignments is how you measure the height of the rectangle. The width of the rectangle was the same every single time. The only thing that's different is the height. and you would use the function that you were given, or maybe a table. You would use the function that you were given to determine the height of the rectangle. Left Riemann sum would mean you would plug in the value on the left side of the interval to get the height. Right Riemann sum, you would plug in the right number of the interval to get the height. Over and underestimation is exactly the same thing as left and right, but depending on the graph, it could be left or right. I guess technically it could be a combination of the two. Midpoint just means you measure from the middle of the interval. Midpoint is extremely annoying to calculate because you have to find the middle of every single interval. And the numbers usually don't work out as good. Trapezoids is the same method as rectangles, except for instead of a rectangle, you would use a trapezoid. So you have to use the formula for a trapezoid to find the area instead. But everything yesterday, the big idea was area under the curve. First topic was geometric curves. Second topic was actual curves. And that was kind of yesterday. So I don't know if there was something in particular you guys wanted me to talk about, or if you wanted to ask about that maybe didn't make sense, whatever. I can certainly do that before we start today. Otherwise, Jackson, I don't know what you were, looking to talk about. How many quizzes were you assigned for yesterday? I have no idea how many quizzes are in the chapter. So what I did is I just assigned the whole chapter. We're not even close to quiz 1 yet, so don't worry about that part. When we'll be able to view our tests? When everybody's done. So I did get everybody's corrected. I did get everybody's test corrected that had finished it. And so you should be able to see your scores. I'm going to guess you can't just open it up and look at individual questions yet. How many activity? So these pictures that I have on the screen right here was me trying to show you what you should have done in Khan yesterday. So yesterday you had these 4 things. That was what you were supposed to be able to complete by today. It doesn't necessarily mean that you've gotten all 4 done already. It was just that was the topics covered yesterday. You guys are going to find that in this unit, the pacing of everything is very much up and down. So like yesterday, these 4 assignments were covered by basically that one topic. Today, we're going to do summation notation. Some of you may know it, some of you do not. Depends on your Algebra 2 teacher. I'm going to cover it as if you don't know it at all. So that's, just go from there. This topic on summation notation and Riemann sums in summation notation can be horribly complicated if we try to rush through it all. So yesterday I wanted Riemann sums. Most people just get the idea that it's estimating area. Today we're going to talk about summation notation, and the purpose of today is to be comfortable using summation notation. The problems today you'll find super easy, and I don't want you to feel like that's going to be this unit. Today's purpose, I'm not going fast today because I want you comfortable with the notation. And then tomorrow we're going to start tying it into calc. Okay, so we're going to put together summation notation and Riemann sums, which is the beginnings of integral calculus. And this third topic, depending on how well everything goes, would be maybe tomorrow, or Thursday. Tomorrow's Wednesday, isn't it? So I will tell you that it's going to feel like the beginning of this unit is going to go very slow. But in my opinion, this is the hardest topic in the unit. And it's mainly because it's so very different than most of the math we traditionally do. It's not that the actual topic is hard. It's just a difficult topic to try to fly through. And then it'll probably feel like we're going much faster once we're done with this. So probably starting Friday. And that's because majority of the rest of the unit will feel very similar to each type of problem. And so since they kind of are all similar, it's easy enough for me to teach them somewhat all at the same time and then just go through a lot of the details with you. But this topic I'm going to take our time on just because it's strange. Does that kind of answer your question on what you've been doing for Khan Academy? Okay, anybody else have anything else they want to ask about before we start summation notation? All right. Then let me get rid of these. I just wanted to take little snapshots so you guys could see to like physically see what was the assignments. So summation notation is a way to add up a bunch of things. I mean, that's summation, right? A sum. And here's an example of, let me change that color. Here's an example of something that's written in summation notation. What happened to my letter? I think that's the same color. Good enough. So this was the original problem here. And this is technically the sigma symbol. I'm really bad at writing it. I've never been good at writing that. It's the real symbol is probably something more like this. And so it would traditionally have that sigma notation instead of my terrible E. Now, if I read this, it's asking me to add up. That's what that symbol represents. Add up the term from 1 to 3. And then you use this equation. Now, I have an n written here. That n could be any variable. It doesn't have to be an n. Frequently, it's an I. And I'm assuming they pick an I for iteration, like, keep repeating, doing something in iteration. But I can be confusing because then I is also for the imaginary I. So this letter can be anything. But basically what you're going to want to do is plug in 1 first, because that's the number on the bottom. So I'm going to plug in 1 first. So I'd have 2 times 1 minus 1. First term. And then I'm going to add, because that's what the sum symbol means, second term. So I'm going to use the numbers 1, 2, and 3. So the second term would be 2 times 2 minus 1. Third term, 2 times 3 minus 1. And I'm going to stop there because I was only told to do the first term to the third term. And then depending on the problem, sometimes you actually find the answer, sometimes you can't. So this one would be what? 1 plus 3 plus 5, or 9. No, I definitely took my time on that one to try to show you what the things represent and stand for. Just kind of curious, before I move on, I don't know how fast I should go. In the chat, could you guys let me know if you have seen this before or not? Or should I approach this as if this is totally new? Okay. Yeah, and you definitely don't need to feel bad if you haven't seen this. That's why I said it almost somewhat depends on who you had for Algebra 2 or how fast they went through the year. Okay. I doubt this was in pre-calc, unless the new book is very different from the old book. Summation notation usually isn't part of pre-calc. Okay. So I definitely saw quite a few no's. So I'm going to keep treating this as if you guys haven't seen it, because I think that's probably the way to go. And if you have seen this and this is easy for you, well, there are worse ways you could spend your time than watching something you already know. It might be boring, but hey. What the heck? What happened to my problem? Oh, I wonder if it got erased when it was underneath that picture. So I am pretty sure this was n equals 1 to 4 of n squared. And I was hoping you guys could do that one. Like on your own, come up with the term values and then the final answer. And my guess is this probably went quick. Jessica Telstad, do you think you have this one figured out? Oh, okay. I actually have zero idea what the answer is. What did you do to get that 30? So kind of like that. 25. Yeah, that's 30. Yeah, good. Nope. I mean, it's as straightforward as that. Okay, excellent. I'll do this example with you. Why not? Darren, let's go with you. Darren, what is different about this problem? Why is this one different than the one above it? Or what is different? I'm not sure what the best way to phrase that would be. And if you're not sure, that's fine too. Oh, okay. Yep. No, that's fine. That's fine. Kelly? Kelly, what about you? What's different about the one I wrote here than the one kind of above it? Obviously the equation, but... Okay, perfect. Perfect. So the bottom number doesn't have to start at 1. Top number doesn't have to end anywhere in particular. So these numbers can be whatever is needed, and I mean, you just go with it. So I might still call it the first term. It's okay to call it the fourth term. There really is no like wrong language there, I guess. But your first answer would come from plugging 4 in. So 4 minus 1. And then I'm going to add the next term, which would be a 5. 5 minus 1. And parentheses would be fine if that helps you separate them. And then 6 minus 1. So 3, 4, 5. So 12. Okay, excellent. I don't know if anybody can see it yet. Can anybody tell how we're going to tie together summation notation with Riemann sums from yesterday? That's what we're leading to. Well, definitely. So yesterday what you guys did was you used rectangles to estimate area, but what you ended up doing was adding the answers to the rectangles. So you did the first rectangle plus the second plus the third plus the fourth. Summation notation is adding up a bunch of things. And so we're going to use summation notation to fit in the information about the rectangles and be able to write an equation out of that. And that's tomorrow. That's not today. Today is all about making sure you're comfortable using summation notation before we tie them together. Okay, so then working our way up slightly. Let me scroll down. I need somebody on the bottom half. Natalie? How about you? What's different about this question than the ones we've done before it? True. What's more important about the fact that there is a K? Okay, that's a good way to describe it too. So we actually have multiple variables in this one. We have an N and a K. Now the only thing we are told to evaluate is the N. Why is that not writing? The only thing we were told to evaluate was the N. So that's the only thing you know how to evaluate. So my first term would be K over 1 plus 1. And I'm going to leave the K alone because I don't know what K stands for. And it's all right if there's going to be a K in my final answer. So like this one would be K over 2 plus K over 3. And honestly, if it really bothered you, you could common denominator these and combine them together. I'm not going to. But the important thing I want you to get out of this is you only replace the variables that it says to. So if this says n goes from 1 to 3, then you replace the n, and you don't do anything with the other variable. And I was going to say, I think this purple one is the last example that we're going to kind of go through together. I've got some for you guys to try. I went and took some examples out of Khan Academy so that you know what the questions would be like. Why don't you guys see if you can do this purple one on your own? It's not a heck of a lot different than the blue one. Yeah. I bought an off-brand ginger ale at the grocery store the other day. It might not be off-brand, but it was different than normal, and it tastes weird. And now I've got 10 more of them to drink, and I don't like it. Let's go with Yuking. Yuking, do you think you could help me with this one? Perfect. Yep. Correct. It's taking me longer to write than it did to you to say. Correct. Once you get the hang of these summation questions, they basically are all the same no matter what kind of things they change. This one I can probably simplify to easy enough. So I've got 4 8Ks. 18 and 18 is 36, and 24, 50, 60, I believe. All right. And this is what I was saying at the beginning of the hour. Today is actually it's by far our shortest lesson of the year. So today you're actually going to have time in class to get your assignment done when we normally don't. And I would expect a lot of you to be done, by 1:35. Now, I also don't have a problem, like, if you guys had trouble with yesterday's homework, I could certainly help you out with that during any of our extra time too. So I've got 4 problems up here. What I did was I went into Khan Academy and I just copied down 4 random problems that I pulled up. And I thought this would be a good way for you guys to see the style you could get on the AP test, because these are multiple choice. Or, just whatever. So question 1 and 3, find what it totals up to. Question 2 and 4, you're supposed to determine what terms these match up with. So what summation notation do they match up with? Why don't I give you guys 5 minutes to do that, and then I'll kind of call on some people to help me out. Or otherwise, if you guys have questions, absolutely just ask them out loud or put them in chat. Whatever works. If you can't read my handwriting, I can translate. Yeah, you don't have to stay on after these. So yeah, when we finish these 4, that's all I was planning on teaching you today. The goal for today was to be comfortable using summation notation. And so you're absolutely welcome to leave the call if you want after this and get some work done. Otherwise, I was just going to stay on the call, so if anybody wanted help with anything. Is somebody that's better at keeping track of time, did they keep track of when we started our 5 minutes? Because I didn't. I know that's shocking. Just a variable. Although I guess it would matter if you squared it. No, just a variable, and you don't actually have to square it out, if that's what you're asking about. Yeah, I mean, you certainly could, but I wasn't looking for that. Okay, are we supposed to combine all these and simplify? Natalie, are you asking about like question 1? I mainly just want to know that if you know how to plug it in correctly. because that one would be a pain in the butt to simplify. And then Darren, I sent you a message. Because you can do direct messages in chat. Can you guys send direct messages to each other? Or is it only back and forth to me? Oh. Good and bad. Okay. You do not, actually, Mary. That's a good question. Oh, you're talking about number 3. I was going to say this is actually going to become whatever number is here, so 0 would be the first term. Tomorrow we learn different versions of this, like similar formulas. So yes, 0 to 3, 0 counts. Okay, so maybe not everybody's done, I'm not sure. But maybe we could just get started. So then that way if people made mistakes along the way, they'd kind of find out. I don't know who I haven't called on for a long time. Ellie? Moss? Have I called on you for a while? Okay. Do you think you could help me with number 1? What did you do for that one? You could have. You didn't have to. No, that's all right. Yeah, you absolutely could have if it bothered you to leave it like this. But honestly, I didn't even check to see what Khan Academy wanted as the answer. I'm just looking for you being able to plug things in correct for right now. So that was your first term. What would have been your second term? Okay, perfect. Perfect. Yeah, this is absolutely why I thought it would be kind of ridiculous to square it. I mean, they just get way too big. Perfect. I just wanted to make sure that you guys were putting the number in place of both J's and not the I, which this is where I was saying my handwriting kind of stinks because I have a problem writing a J. Excellent job, Ellie. Thank you. Mary? How about 2? You did. Okay, how come you put both? Did you just kind of like figure out both of these separately and then try to match them up with the one up there? Okay. Yeah, that's probably what I would have done too. There's not necessarily a shortcut to this. Okay. So plugging 1 in would have given us 3 minus 1, or 2. Second term would have been 6 minus 1, or 5. Third term would have been 3 times 3, 9 minus 1, or 8. I'm running out of space here. And fourth term would have been 12 minus 1, or 11. So that does match up. Okay, definitely A works. B, 0 to 3, would be 2 plus 3 times 0, or 2. 2 plus 3 times 1, or 5. 2 plus 3 times 2. And then 2 plus 3 times 3, or 11. So absolutely. These both ended up having the same first 4 terms. Okay, nicely done. Anybody else maybe have a question on 2, like how to approach it, or anything like that? I wanted to include these in our practice questions because, like, when I looked at the Khan Academy homework, I absolutely noticed that they had different styles of questions, even though it's asking the same information. Okay, otherwise we can move to 3. All right down here. Haley? Haley, can you help me with 3? Okay. Okay, so what was your first term? Okay, good. 3 times 0 minus 7j, yeah. Okay. Excellent. The 7j stays the same the entire time. Good. Really the only difference between question 3 and question 1 is question 1 had the same variable in both terms. Question 3, the variable was only on one of the terms. So then that 7j stayed the same every single time. This one actually wouldn't be horrible to combine if I wanted to. I would get 18 minus 4 7j's. I'm not worried about what you guys did. Okay, 4. Maybe I'll just go through it quickly, since I think you guys kind of have the hang of this now. Okay, so on question 4, my first term is 5 minus 8 times 1. My second term is 5 minus 8 times 2. So far it matches up. 5 minus 8 times 3. And then 5 minus 8 times 4. It looks like this absolutely matches up with this, with A. So A works. B, plug in 0. 0 minus 3 gives me negative 3. That one matches up. Second term would be 6 times 1 minus 3, which is 3, and it is not negative 11. So immediately B is out. And since A works, it can't be both, and it can't be neither. So it is A. And I wouldn't even need to finish B, because as soon as I realize that the terms don't match up, all 4 terms have to match up. Okay. I'm not even going to ask, a fist of 5 today, because I have a feeling I'd have a lot of 5s. Today was admittedly not supposed to be difficult. Today is just to get you comfortable using the notation. So I'm not trying to dupe you into thinking that this unit is going to be a lot easier, because it absolutely does get harder. I mean, each unit we have is harder than the one previous. Most of the time, it doesn't feel harder. Yeah, I know. Granted, I know a lot of you say you wish all of Calc was like this, but I actually have a feeling you mean you wish you could do all this for your grades. Because it's actually super boring to do easy stuff. And you may not believe me yet, but I guarantee some of you, especially like if you're a junior, right? So if you're a junior right now and you're in Calc and you realize you're never going to use Calc. So instead of taking Calc BC, maybe you're going to take like CIS College Algebra. Because if you're going into a profession that doesn't need Calc, like this is a pretty difficult class just to take for fun, which you absolutely can do. But most people don't just because it's so difficult. And so if you go into CIS, what's it called? CIS math modeling, you are going to find how ridiculously boring that class is when you have to sit through a class that you already know how to do. So being in a difficult class is stressful. But you're actually probably going to find that you guys will like that as you go through schooling, because it's really boring to take classes that don't challenge you. Like it just, like you get me personally, I get super annoyed like watching stuff that I already know. Like I had a student Mrs. Young. So Mrs. Young was my student teacher, I don't know how many years ago. I never realized how hard it would be as a teacher to sit through and watch your own classes. It's horrible. And so I know your guys' pain. It's hard to sit through something for quite a while. It's why I try to involve you guys as much as I can, because it can be pretty rough. So anyway, my point is, it's definitely getting harder. It's not like it's going to be impossible. It's definitely going to get harder than today. So I would take the rest of the hour today. You've got about 30 minutes left, 30, 40 minutes left. Do today's homework, and I can put those snap screenshots back on if you want. Maybe. Yep, there's one. Okay. So here's the screenshots again. So if you did not have a chance to finish yesterday's homework was these 4. And they aren't horrible either. I mean, like it basically is adding up rectangles, but it's just not something you can fly through. So that's why some people dislike them. This is the only thing I would like you to do from today's homework. This is for, This is for tomorrow. And this is for maybe tomorrow. So you guys have plenty of time to work on these today to get caught up. And I'm going to stay on Zoom. So if anybody wants to ask questions on homework or just, whatever, that's fine. So I'll stay on here until I'll basically be on here until 2:15 because that's when the open help session ends. You guys are welcome to leave at any point here now. Appreciate you coming. I know it's kind of forced because of attendance, but I still appreciate you coming. And I'll absolutely see you again tomorrow. You bet. Yeah, you're welcome.